Hello students, we're going to talk about the distance formula. Distance formula is really good if you have a line segment and you would like to know the length of the line segment. Again, line segments have two end points. So if you know these four numbers, the x's and the y's, and you know where to put them in the formula, then you can use this formula to find the distance. Let's practice. So this one has a triangle on a coordinate plane, and we want to know how long KL is. This is asking you to find the distance between K and L, or the length of line segment KL. Line segment KL is right here. So in order to start this problem, it would be helpful for us to know what are the x and y for point K and what are the x and y for point L. K is at 1, 3. And L is at 1, 2, 3, -2. 3, -2. Okay, once we have those numbers, we can go for the distance formula. Distance formula, it's a good idea every time you use a formula to practice writing it. It's the change in the x's squared plus the change in the y's squared. Okay. In this problem, we're trying to find the length or the distance between K and L. And we can do that by putting the four numbers in very carefully, paying attention to details and not getting screwed up all the way. This is the x and this is the x. I'm going to do 3 minus 1. 3 minus 1 in the formula, and then I'm going to do the y's. So this is -2 minus 3. -2 minus 3. This is the x and y of the second point, and this was the x and y of the first point. X sub 2, y sub 2. Sub stands for subscript. Okay, then you plug and chug. You be careful with your integer work. 3 minus 1 is 2. So this is 2 squared. -2 minus 3 is -5. Distance is always going to be positive, so the squareds in here are really nice because if there's a negative number inside, it's going to make it positive after you square it, because a negative times a negative is a positive. Okay, then we find that KL is the square root of 29. That's a beautiful answer. If you want to know what that is on a calculator, you can type it in. It'll tell you, well, the square root of 25 is 5, so it's 5 point something. 5 point, I have a calculator right here. Square root of 29. 29 square root is 5.38-ish. It says round to the nearest 10th, so I should have done 5.4. Okay. In math, we like the exact answer better, but if it asks you to round, then you should round the indicated place value. Look, they got it. The same thing I did. All right, let's try another one. So we want to find the length of line segment PQ again. We know that we have, now we don't have the picture, we just have the numbers. So we're going to very carefully put our x and our y in, and our x and our y in. This is x sub 2 minus x sub 1 squared. This is y sub 2 minus y sub 1 squared. The change in the x's plus squared plus the change in the y squared. I want to find PQ. That's the length of line segment PQ. And I'm going to do, well, how about 7 minus -5? And I'm going to do -5 minus 4. That's the change in the y's. -5 minus 4. Plug and chug, be really careful here. 7 minus -5 is the same as 7 plus 5. 7, 8, 9, 10, 11, 12. That's 12 squared. And -5 minus 4 is -9. 9 squared. So we have the distance from P to Q is the square root of 144 plus 81. Okay, put that together and you get 8, 5, 229. Nope, 225. All right, so that happens to be a perfect square. The square root of 225 is 15. So those points are exactly 15 apart from each other. It's kind of cool. All right. So here's an interesting one. We could do the formula on all of those, but if you take a second and you sketch what this looks like, there's a really easy way to do the first 3. What's interesting about the first 3? Let me show you. So let's look at 11, and we have a situation in problem 11 where we have a point at 6, 8, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to call that right there. That's point A. And we have another point at -1, 8, which is right there. If I want to know the distance between them, it would be a little bit silly for me to do the distance formula on this one. What's a lot easier is to say, hey, wait, they're in a straight line. This is a flat slope. So I can just count 1, 2, 3, 4, 5, 6, 7. Answer to this problem is that AB equals 7. How did I do that? Well, they're along the same horizontal. So I only have to find the difference in the x coordinates because 8 minus 8 is 0. So I just have to find how far is it from 6 to -1, and it's 7 units. Okay, same idea here. So these 5s are the same, right? So how far apart is 6 and -6? Answer to this one is that CD equals 12. To get from -6 all the way up to 6 is 12. Okay, how about this one? What's the same in this one? They're both have 0 for the y value. So these are both on the x-axis. This is -2, 0. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11, 0. So how far apart are they? What's the distance between points E and points F? 11 to get to there, 12, 13, 13. So sometimes you want to use your brain and not go for the big formula all the time. This is a great one for you to try and see if you can get to the answer. Notice they're not straight in a line. So you would have to use the distance formula for this one. All right, geometry is the language used to talk about shapes and their relationships. Have a good day, do your homework, be good.